What's going on, everyone? Welcome back to another video lecture in the AI for Aspiring Researchers video lecture series. In this lecture, we're going to be going over decision trees and random forests with the FIFA player dataset created by Karan Gadia, and it's in Kaggle. The link for the dataset is posted below. Make sure you check it out. It's really good. Now, if you don't know what FIFA is, it's basically all the soccer players kind of combined into one game, and each of these players are given different ratings, right? So the higher your rating is, the more skilled or the more kind of better, I suppose, for lack of a better word, your player is. And so each of these players are rated on each of their individual skills and given an overall rating. So what we're going to be doing in this kind of assignment is, given the players that we see and their skills, given the rating for their skills, can we predict what their overall rating is going to be? Right, so let's jump right into it. The first thing that we're going to do, as always, is import the necessary libraries. So we're going to say import numpy as np. Now, if you don't already know what these libraries are, feel free to take a look at my other videos earlier on in this lecture series. I talk about some of the main ones like NumPy, Pandas, Matplot, and exactly what they do. And with that being said, we're going to also import Pandas as pd, and we're going to say import matplotlib as plt. We're also going to say import sklearn, from sklearn.model selection import train test split. Now, if you don't already know what the train test split is, what it's doing is that whenever we're training our decision trees or random forests, we need to kind of take our data set and break it into two parts, a training part and a testing part. So the training part, as you can kind of tell, is used in the training phase for our decision trees. It's what makes our decision trees much stronger. And the testing part is to see, well, how well are those decision trees acting for newly seen data, right? So what this train test split is doing is it's automatically splitting our data set into two different parts, into a training part and to a testing part. Right, so now from sklearn.preprocessing import standard scalar. Now, I feel like it would be better to explain this library a little later. So when we come to that, I'll go ahead and explain that. And we're going to say from sklearn.ensemble import random forest classifier. Right, so what this random forest classifier does is it automatically creates a bunch of decision trees and trains our training data set on the random forest. And you can kind of see that, like, right, if you haven't heard of random forest, what is it? Right, so a forest is just a bunch of trees, and similarly a random forest is just a bunch of decision trees. And so essentially the idea of a random forest is that when you have a bunch of decision trees, the kind of average or some sort of mean of all of these smaller decision trees will get us to a much stronger output or much stronger value in the end that is more accurate to what we're comparing it to. Awesome. So let's go ahead, run that. Whoops, let's go ahead and run that again. Okay, now what we're going to do is, you've seen this multiple times, we're going to set our data frame is equal to pd.read_csv, right, because we have our CSV file, and then data.csv. This is what is stored, or this is what I kind of inputted it as, a data.csv file. And what we're going to say right now is df.head, right, and that's going to print the first 5 values of our data set, or of our CSV file. Right, and so you see this table here, you see a bunch of different values, right? And what we're going to now do is take a look at this a little closely. Right, so when we see these first few values, you might have heard of these names. So this is Lionel Messi, Cristiano Ronaldo, Neymar Jr. This is the age, this is the photo. So the data set, what it's essentially saying is that for each player, they have an associated photo with them, and it's stored at this URL. The nationality, the flag photo over here, and this column right here, this is our overall column, right? This is the player's rating overall, right? So you see Messi and Ronaldo at rating 94 and Neymar Jr. at rating 92. Potential is over here, which is their, like, I guess, potential skill. What's the highest potentially rating that they could get? You see their value, wage. I'll kind of skip forward a little bit. Over here you see kind of some numbers. Over here, height, weight. Now, if you don't know what these means, kind of ignore them for now, because we're not going to be using them. But over here, these values over here, from crossing onwards, are the important values, because these are the different skills that a player can have, right? So crossing, finishing, heading accuracy, short passing, volleys, and so on and so forth. These are all skills that they can have. Right, and so let's take a look at the first row, which is essentially Lionel Messi. Right, so the first row, for crossing, Lionel Messi is an 84 in rating. For finishing is a 95, and that makes sense because he's a forward player. He attacks a lot more on the ball, and he scores a lot of goals, and so he's going to be higher rating on those. And similarly, you see kind of over here, stamina, 72, kind of, what else is there? Sliding tackle, 26. Now, you might wonder, wow, this is one of the best players in the game. Why are their scores so low over here? Well, for our purposes, it really doesn't matter, but if you are interested, he is a forward. And typically, these stats over here are dedicated to more defense players or goalkeepers, right? And so you see this fourth row, which is one of the best goalkeepers, has a significantly higher ratings in the goalkeeper kind of variables or positionings or skills, right? And so essentially what we're going to do is we're going to take all these things into account, all these different values for skills, and we're going to try to predict their overall value, right? And so how do we do that? Well, the first thing that we need to do, and this is kind of good practice for any data set or any data frame, I should say, is say data is equal to data dot drop NA. Now what this does is, if there is, say, a value, right, if there's a value in one of these columns that doesn't exist or is given just the value NA or not available, then it'll get rid of it, right? It's going to get rid of that value and we don't consider it. And you might think, well, what's the really big deal if it doesn't have a value? You can kind of just skip over it. Well, it might cause some errors in the code, and it might actually give sometimes incorrect accuracies by associating it with a completely random number, which is completely wrong, right? And so for that, this is typically really good practice to just say data is equal to data dot drop NA or something of the sorts. Right, so let's go ahead and do that. Oh, data is not defined. Oh, that is right, because I forgot to do one thing in between. So I kind of want to mention this because it's actually pretty important. I completely forgot about this, but you see that some of these values don't really matter. They have no significance to the overall rating, right? So the URL of a photo of a player or a flag has nothing to do with the rating, or maybe the club really doesn't have much to do with the rating, as opposed to their skills, right? So these skills play a heavy importance to the rating. And so what we're going to do is we are going to say data is equal to df.drop. Now what this is going to do is it's going to drop some of these unimportant columns for us, right? So this unnamed 0 is kind of an unimportant column, so we're going to say unnamed 0, right? And then we're also going to say ID, then we're going to say photo, also we are going to say flag, we are going to say club logo. Now I have actually these written out prior, so you can just kind of look through the data set. I won't go through them, but if you want to check out what exactly these columns correspond to specifically in terms of numbers, you can feel free to check that out. Okay, real face, loaned from, but I guess from the column names you can kind of tell that, well, these don't really seem like they matter, right? So jersey number, it doesn't really seem to make too much of a difference what their jersey number is. And same thing with, like, say, contract valid until, right? And then we're just going to say axis 1 so that our program knows we are dealing with columns. And we're going to now say data.head just to see new data frame, the new data frame, and we're gonna say shift run. Awesome. So now you see that all these kind of excess columns or these unnecessary columns have been removed, right? So we don't have our photo or flag, it goes directly Lionel Messi, age 31, nationality Argentina, overall, blah 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 blah, so on and so forth. Okay, now what we can do is we can have this thing run data is equal to drop NA, and what that's going to do once again is it's going to drop any of those NA values. Okay, so now let's take a look at what we're dealing with. Okay, so in this data frame, well, all we still really care about is these values from crossing to essentially goalkeeper reflexes. These are the only values that we actually care about, and they're the only values that are really going to impact the overall rating of a player. And so, well, I didn't really want to go ahead and list out every single column that hadn't or wasn't really important. So what we're going to do is this. We're going to say first underscore column is equal to data dot columns dot get underscore LOC, which is get location, and then we're going to say crossing, right? And then we're also going to say last column is equal to data dot columns dot get underscore LOC, and then goalkeeper reflexes. Okay. Now what this is essentially doing is it's getting the location of our crossing column. So it's going to get the index, kind of, you can think of it like that. It's going to get the index of this crossing column. And similarly for last call, it's going to get the index of this goalkeeper reflexes column, and it's going to store those in first call and last call respectively. Then what we're going to say is stats is equal to data dot ilog, and then we're going to put colon first call, and then last call plus 1. Alright, so what this is going to be doing is it's going to store stats as essentially all the values in all the columns between crossing and goalkeeper reflexes. So what this first colon over here means is essentially it's saying get all the rows for the entire data set. Get all the rows. And this second value, or the second kind of parameter, quote unquote, is saying, well, the only columns I really care about are the columns from index whatever this index was, because that's what the first call is, to index essentially whatever this one was, inclusive of both. And that's kind of what that plus 1 is, just an inclusive for both. And we're going to say dot values, right? Because we want these values, we want these numbers over here. Those are that we say dot values in order to get those. Alright, so now we're going to say print stats. Okay, and you can see exactly that, right? So you see these values over here. These are the values that essentially correspond to these players for crossing all the way to goalkeeper reflexes, right? And so you see 84, 95, 70, 84, 95, 70, right? So this first row is Messi, the second row is Ronaldo, and so on and so forth for all the players in the game. Okay, now what we're going to do is we're going to say rating column. Rating column is equal to data dot columns dot get underscore LOC, and then we're going to say overall, right? So what this is doing is because what we need really is we also need to get the actual ratings for these players for our training data set, so that our random forest, whenever we go ahead and create that, it actually knows that, well, these values, these values for the players, right, the skill values correspond to these overall ratings, right? And so we need to go ahead and do that over here. And what we're also going to say is rating is equal to data dot iloc, or ilocation, colon rating underscore column to rating underscore column plus 1. Right, so what this is going to do is it's just going to get all the rows. Once again, that's what this first colon means. And then it's going to get rating column only, right? Because rating column plus 1 just means it's going to be here, here, but this is exclusive, right? This doesn't really count. So the only column that we actually care about is this overall column. Okay, now just to check that, we're going to say print rating and run it. Oh, this seems to be wrong. What is the issue? Oh, I see. My bad. This should not be parentheses. They should be brackets. That is important because this is not a method, right? It is trying to get the indices or the actual values from data, right? So let's go ahead and run that again. Okay, awesome. So you see that essentially. Oh, and one more thing I forgot to say. Dot values, right? Dot values. Okay, so now you see that these are the player ratings. So you see, once again, Messi is 94, and it's kind of by row, right? So the first player, second player, third player, onwards until you get to the lowest rated player in the game. Awesome. So now what we're going to do is we're going to also split our data set, or split this set into our training and testing data sets. So I mentioned earlier that I would talk about exactly what the train test split was. Here we're going to see that. So we're going to say stats underscore train, stats underscore test, rating underscore train, and then rating underscore test is equal to train underscore test split, and then stats rating, and then test size is equal to 0.25. Okay, so let's take a look at this more in depth. Right, so you see that this training test split takes in a couple values, so it takes in our stats. Now remember, our stats is essentially this 2D array right here, and it stores all of the values for the skills, or all of the ratings for each person's skill. It takes in rating, which is just the overall rating for each player, and it takes some parameter called test size, and we set it to some kind of number between 0 and 1. Now, what test size is basically doing is it's basically saying, okay, how much of the set do you want to be the test? And 0.25 means 25% of the set will be the testing set, and then the rest of it will go to training. Right, and so let's go ahead and run that. And automatically what it does is it stores in our stats train and rating train the training data set, and stats test and rating test the testing data set. Okay, so now for the thing you've all been waiting for is the actual, oh wait, no, sorry, there's one more thing in between, I'm so sorry. Okay, let's do scalar is equal to standard scalar, and we're gonna say then stats train is equal to scalar dot fit underscore transform. I was waiting for that to finish for me, but I guess it didn't. Stats train. We're also going to copy paste this for our testing. I'm just going to change that to test. Similarly over here, test. And we're also going to say now, just to make sure that this is going well, we're going to say stats underscore train. Awesome. So essentially what we're seeing here is the values that are kind of getting scaled down, right? So we see stats train, and we're scaling it down to these values. Now, what exactly is this doing? Well, if say we didn't have the scalar, the decision tree would take a really long time to, or if even it will do it, it'll take a really long time to actually create a good decision or good random forest or good kind of values or accurate values. And the reason for that is because over here we're dealing with numbers that are close to 100. They're really big numbers. And so what we need to do is we need to scale it down to very small numbers, so that whenever we train on our decision trees or random forest, the training algorithm will kind of shift these numbers slightly, and that slight movement will make it more accurate. Right. And so now let's say rating underscore train, just to see what exact values we are getting. And so exactly what's happening here, right? So this is essentially the values that we're getting for the training data set as our final values, right? So these are the final values for our training data set. Okay, now Now, what we're going to be doing is creating our random forest. So we're going to say classifier is equal to our random forest classifier, and then n estimators we're going to set as 100. Now, n estimators, basically what it means is just like essentially how many decision trees are there in this forest. That's what estimator means. Alright, an estimator you can think of as a decision tree. Criterion we're going to set as entropy, and then also random state is going to equal to 2, something just random. Okay, then we're going to also say classifier, or sorry, dot fit, and we're going to say stats underscore train, and rating underscore train. Okay, so let's take a look at this. So what it's doing is essentially saying this classifier is some random forest classifier with 100 decision trees, some criterion and random state. This you can kind of ignore for now. And then we're also going to say classifier dot fit stats train and rating train. Now this should be fairly obvious. What that's doing is it's basically fitting our model on the training data set given whatever statistics we have or the stats that we have for each of these players and the corresponding rating. So now what we're going to do is run it, and it's n estimator. It's supposed to be n estimators. That's fine. Okay, so this might take some time, and the reason is because we're running it for 100 estimators, but it should be fairly fast, I hope, because we're running it on a GPU. Okay, cool, it's done. Okay, so now what we're going to do is we're going to say rating underscore list is equal to that, and now we're just going to say for I in rating underscore test, and then rating underscore list, rating underscore list dot append I 0. Now what this is doing, and I guess there are other ways of doing this, please feel free to use anyway, but basically I'm just taking all the values of the ratings and throwing them into one list, so that later on whenever we want to kind of check between two things, it'll be easier to see that and then just like plot them, or it's just easier essentially to do it this way and to visualize the data when you create all of them in a list, as opposed to say here where you see that rating is in a 2D array, and so this was just something I would maybe recommend doing, or maybe if you have a different way of doing it, that's also fine. Okay, now we're also going to say rating underscore pred, which is just the predictions for our ratings, is going to say class is going to equal to classifier dot predict stats underscore test. Now this should be fairly obvious. What this is doing is it's that the classifier that we fit our kind of training data set on, we're now feeding it the testing data set and expecting some answers, and those answers are going to be fed into this rating predictions, right? And so now what we're going to say is finalized underscore data is equal to now actual value, and we're going to say rating underscore list, and then we're going to say predicted value, and then we're just going to say list of rating underscore pred. Now once again, this is just for purposes of making it easier to see and kind of read. And now what we're going to also do is create this finalized underscore data into a data frame. So we're going to say this is, instead of data, we'll call it finalized df. We're going to say now pd dot data frame and then finalized data. Right, so what it's doing is it's storing this rating list, like the actual values for the ratings, as actual values in this dictionary, and then whatever we predicted as the predicted values in this dictionary, and then finally it is also creating this data frame from this dictionary, and you'll see that just here. So we're gonna say print, or let's actually just do this way: finalized underscore df, and we're just gonna say dot head. Okay, awesome. So you see these values, these are the actual values of the players in our testing data set, and the predicted values. Now, immediately off the bat, you can see that these actually, our random forest classifier actually did pretty well. Given the stats, it was actually able to predict the overall rating not bad. You see a 71 when it was actually a 72, a 60 when it was 61, 70 when it was 67. I think this is probably one of the more off ones of like 3, 68, 67, 64, 62. It's pretty good, pretty good. So now what we want to do is we also want to kind of see the differences. We also, like, these are just the first 5 values, but we want to see, okay, more than that. Okay, let's say diff is equal to this, and then for I in range, and then we're going to say length, and then we're going to say finalized df dot index, and then diff dot append. Now this is optional. Feel free, if you've already think that you can understand kind of random forest, feel free to exit this video. I think this is just me playing around, kind of seeing how well our random forest classifier actually did. But from the first like 5 values, you can already see that it was doing fairly solid, and so this is just kind of reassurance per se. You can kind of say, alright, dot ilog, and then we're just gonna say I, and then 0, 1, dot values, 0. Okay. Let's run that, see if that works. Hopefully it does. Yes, it does. And then we'll just say plt.plot diff and then plt.show. So this is just showing the difference. Now what this is doing is it's essentially calculating the difference between all of our actual values and all of our predicted values and storing them in this diff list. And then now we're just going to go ahead and plot that. Okay, so now you see plt.plot. Now what basically I'm doing here is, instead of just printing out or plotting the difference between two things, the difference between our predicted and actual, I actually want to predict, or I actually want to plot, sorry, the predicted and actual values. So we're going to say plt.plot list and then rating underscore pred, right, and then plt.show. Okay. So essentially what this is doing is we're just seeing kind of how close, and I guess this isn't really that helpful, but you can kind of see sometimes that these are fairly close values in general, considering the amount of overlap. There's not a really big like difference between them, and you can also see here that the values over here, the difference, like the max difference, which is kind of an outlier over here, is 8, right? It's 8 over here, and you see a majority like between 1 and 2. And so that means that our random forest classifier was actually really good. And you can kind of play around with this. So right here I chose n estimators as 100. Feel free to change it to 200, 300, depending on how good your computer is. You can even do 1,000. Not recommended, just considering how, I guess, simple this data set is, and 1,000 would take some more time. So feel free anytime, go ahead, do that, change up criteria on random state, and play around with essentially different values. Right now we did this for classification. You can also use decision trees for regression modeling and for regression prediction. And so decision trees are a really strong thing. I believe an ensemble method you can use with them, and they're really good for the field of machine learning because they're able to predict, and it's really simple to code, as you saw, and it's pretty intuitive, right? All you have to do is kind of, and you saw here a majority of what I did was just kind of data processing, right? It was actually kind of seeing what values of here were important, gathering those values, scaling them down into a size where the model might do better, and then finally we ran them towards the end on this random forest classifier. But overall, that was random forests. If you like this video, feel free to subscribe, like, comment. Please, if you have any questions, also feel free to leave a question in the comment. I will be more than happy to make a video on a question or a new topic suggestion, and I can't wait to see you next time.